Let's take a look at this bad boy. Find the power series for f of x equals ln of x. And I guess the interval and radius of convergence. So, I would have really liked it to be ln of 1 minus x or ln of 1 plus x or something. But I think we should be able to do a little bit of trickery and get a response and get an answer for this, I think. Well, let's note that f of x equals ln of x, which I guess if we were a bit clever about it, we could write this as ln of 1 minus the quantity 1 minus x. I see what we did right there. Kind of forced it a little bit. And that's sort of where we're going to be going with this. I realize that this might be a little bit of a sort of a complicated derivative, complicated looking derivative. But just remember that if the derivative of ln of x is 1 over x, so we could rewrite f prime of x equals 1 over x, then we could really rewrite this as 1 over 1 minus 1 minus x, right? That's sort of where we're going with this, okay? Right, so what we're going to say is, just to write this a bit nicer, f of x equals the integral of f prime of x dx, of course, right, which is the integral of 1 over x dx, and maybe this is better written as, again, as we see right up there, 1 over 1 minus the quantity 1 minus x dx. Okay. And now, see, now we've got our radius of convergence that we have to be concerned with, right? We can use 1 minus x in our series, right? In our power series. But we have to make sure that we're using the right values of x, right? So for 1 minus x strictly between negative 1 and 1, which is really like saying, so let's see, if we subtract 1, we get negative 2 is less than negative x, which is less than 0, which I guess means x between 0 and 2. We have that f of x equals the integral of the power series from 0 to infinity of 1 minus x, right, that quantity to the n dx. Let's see how we get that? Right, again, this is the guy we're raising to the n, right, because we're assuming it's between negative 1 and 1. Which is fine, right? We're doing sort of a negative shift, right? An inverted shift of x, so to speak. Okay. Now, I guess the tricky part here is that it's not the nicest thing in the world to integrate this. But I guess if we're a bit clever about it, then we could do a u substitution, couldn't we? All right, maybe we're going to do a u substitution. Put this in parentheses, right? Let u equal 1 minus x. And I guess that means that du is going to equal negative x dx. Well, sorry, negative x dx was wrong with me. Negative dx. Except we don't actually have a negative, so maybe du is going to be negative. Okay? So let's just continue with this, right? And we don't even have any bounds, so we don't have to worry about any of that substitution nonsense, right? So we're going to get the sum 0 to infinity of u to the n times negative du. Of course, we can stick that negative sign out, outside the integral, and we will do that, right? But when we integrate, we're going to get negative 1 over n plus 1 times u to the n plus 1 plus c, of course, right? And that's going to equal negative 1 over n plus 1 times 1 minus x to the n plus 1 plus c. All right. Now, I guess we have to be a little careful, right? Remember, we can solve for c in this case because we were given the original function, right? So because we were given this, we can potentially solve for c. Okay. Maybe I'll save the highlighting for this next line right here and say that since f of 1 equals 0, right? Do you see that f of 1 equals 0? Right? F of 1 equals ln of 1, which equals 0. But on the other hand, that really equals negative 1 over n plus 1 times 0 to the n plus 1 plus c. We have c equals 0. Okay, so I'm going to continue this sort of up here. Actually, first let me just highlight this right here. Right? And maybe I will actually highlight that just to show you where we're going. Okay. So really, we can actually even do a little bit better than what we had before. F of x really... Oh, shoot. Sorry about this, guys. I committed my classic faux pas of neglecting the summation sign. I do apologize for this. Whoop. Let's get that summation sign back in there. Right. Right. Just slip the summation sign in there. Right. We are summing this stuff up. Summing it up. Okay. Summing the whole thing. Okay. Summing all of that. Maybe I'll move that a little bit closer just so you can... Oop, no, that's messy. Let's not mess with that. Right? A little bit more blue highlighter, and we should be good. Excellent. Anyway, so f of x equals the sum from 0 to infinity of negative 1 over n plus 1 times 1 minus x to the n plus 1. No plus c, right? Because c equals 0. And maybe we can even erase the period and say, with interval of convergence, (0 to 2). And radius of convergence, radius of 1, right? Okay, so that's our answer right there, right? So again, a little bit more challenging than what we'd seen before, right? Because we had to be clever about writing ln of x's derivative as 1 over 1 minus something, and then we had to just be a little bit careful with our u substitution, okay? But we were able to get a power series. It's not the nicest thing in the world because you don't have like a clean expression of x to the n the way that we might like. And using the binomial formula, there is a way of getting this, but that's really not worth our time. Okay, so that's how you do it.